This is SAHA tutorial hub, and today I discuss our linear programming problems. A problem of maximization through simplex method, very important method. So let's start. There is a problem given maximize z, max z. This objective function has to be maximized given that 4x1 plus 14x2 subject to the constants given 2x1 plus 7x2 7x2 less than equal to 21, and another constant given 7x1 plus 2x2 less than equal to 21 and x1 and x2 non-negative, x1 and x2 non-negative constant greater than equal to 0. So I first have said that I will use simplex method. You can also use the graphical method because there are two region variables. So graphical method also give you the optimal solution. But to learn the simplex method, I am solving this simplex method. Here you are looking at both constants are less than equal to, so we need two slack variables. If greater than equal to, then we need to use surplus variable because these are less than equal to constant, so we will use slack variables. So we are taking two slack variables x3 and x4 and rewrite this equation in this way. Make z equal to 4x1 plus 14x2, and these are slack variables just introduced. It does not affect the objective function, that's why its coefficient will be must be 0. So I am taking 0 coefficient for both the slack variables, and the constants will be now equation. So what will be? This will be 2x1 plus 7x2 plus x3, 1x3, coefficient will be 1, x3, and here just one slack variable is used, another is 0. So another is putting 0 equal to 0. Now this is an equation, and the other constant will be changed in equation in this way. 7x1 plus 2x2 here I use x4 the slack variable, so x3 will be the coefficient of x3 will be 0 and the coefficient of x4 will be 1. So you also look that here 1 0 and 0 1 forming two linear independent vectors, which you can introduce as a basic you can use x3 and x4 as basic variables. So let's start now. I am constructing table. And use this is a1, this is a2, and this matrix form, this column matrix is a1, this column matrix is a2, and these are A3 and A4. This is A3 and this is A4. So let's start to construct table. So to construct table, we have to remember many things. First table, table 1. Table 1 will be in this way. There will be 7 columns. 1, 2, 3, 4, 5, 6, 7, and 4. There will be 4 rows. 1, 2, 3. I will take one more. This is 4. So here we have to first put the coefficients of the objective function. This will be denoted by Cj. So these are I have done in my exercise book. So I am writing through this exercise book. The objective function's coefficient was 4, 14, 0, and 0. I am reading another pen. Now there will be the uh, objective function related with the basic variables. So the basic variables we will take A3 and A4. The column matrix will be taken as a basic independent vectors. This is denoted by AXB. So I have taken A3 and A4. A3 and A4 will make the basis for the initial solution. So the related basic variables will be X3 and X4. And you can look this, the objective functions of A3 and A4 is the 0, 0, 0, 0. Now we have to leave a more column. Is the function B. The function and here we will put 21, 21, 21, 21. The right hand side of this equation. I have done a mistake also. And the subject to constants I am writing here again. I have done this mistake that this will be 2x1 plus 7x2 plus x3 is equal to not equal to 0. This will be 21 and I've given in the earlier in earlier figure this is equal to 0 but not equal to 0 but this is equal to 21 and this will be 7x1 plus 2x2 plus x4. This is also equal to 21. Sorry for this mistake. I hope I will not do another mistake. So 21, 21 will be the right hand side values. We'll put under B, small b, and now we'll use the all the uh, all the coefficients of the variables of the first equation. So this will be 2, this will be 7, this will be 1, and this will be 0. And there it will be, sorry, not in this slide, this will be A1, this will be A2, this will be A3, and this will be A4. Actually, in this line, this will be 2, 7, 1, 0, and there will be 7, 2, 1, 0, 1. So now we have to calculate what is the value of Zj minus Cj. Zj minus Cj. So here Cjr for this row column is 4. So Zj, how it is calculated? Zj is equal to Cb plus xb. So xb actually are 4 xb here. 1, 2, 3, 4. So CBR 00 just. So we put in the place of xb value first columns value. So these are 0 and 2. There will be summation also. So this will be multiplied 0 and 2 0 plus 0 into 7 0 and minus Cj is 4. So this will be minus 4. In this way this will be also 0 0 and this will be just minus 14. Here again it will be just 0 and 0 and this will be again 0. So the rule says that if any Zj minus Cj is greatest negative, then this must enter in the basis matrix. Here our basic matrix is A3 and A4, formed by A3 and A4. So we are we are looking that A2 is A2 vector is more negative vector, so it will enter and one must be go away from this basis. So if we enter this, so which one will keep out from this basis matrix? So we have to verify in this way. We will divide b by a2 this and b by this, and we will find out minimum of this. So this will be minimum. 21 and 7 divided is 3, so this will be minimum. So this is the key element. We will say this will say that key element, and I am marking another. This is the key element and it is related with A3. So A3 have to go away from the basis element. Then what will be the further? If we draw the table 2, table 2, all the things are same, just the data will be changed. How the data will be changed, I am giving, I am explaining this. So now data will be changed in this way. Now our basis is formed by, here will be A2 and the other will be A4. Now the objective function coefficient of A3 is 14 and this is 0. Here this will be x2, the related basic variable x2, and there will be x4. Now these are same 21, 21, and we have to need to calculate it 1. So we divide all the elements with 7. I have done here again my mistake. Sorry for this. This will be not. Actually, this will be x4. This will be there. We need 2 here to create 1 0. So we need to first generate here 1. So we divide 7 by 7 with all the rows. So there will be 3. There will be 3. There will be 2 by 7. This is 3. This will be 2 by 7. This will be 1. This will be 1 by 7. And this will be 0. And here we will get, we will divide 21. This row is substituted by elements in this way. We will use old element minus related row element, and related row element is 2 by multiply key element. This is 7 by by related column element. Actually, this will be 21, and the related row element related row element, related column element, and related row element. This will be 21 multiplied 2 divided the key element 7. This key element. So we will get 7 multiplied 3. So we will get 15. Here we will put 15. Then how this will be? There will be 7, the whole element, minus 7 minus, here 2 multiplied 2, 4, 4 by 7, 7 by 4 by 7. So if we calculate it, it will be 4 by 7, 49, so 45 by 7, 45 by 7. There will be 45 by 7. And here we will get here 7 minus 7 minus 7 into 7 by 7. So 7 minus 7, here will be 0. Here we will get 0 minus 1 multiply 2, 1 multiply 2 by 7, minus 2 by 7. And here we will get 1 minus, this will be 1 minus 0 multiply 0 multiply means 0. So there will be 1. So we are getting that these are linearly independent vectors. So we need to find out Zj minus Cj. So I am erasing this now. It is not necessary now. So here will be There will be, first we calculate Zj minus Cj, Zj minus Cj Cj. So Zj minus Cj, here is 14 and there is 3. So 14 multiply 2 by 7, this will be 28 minus 4, 32. Mistake I agree. 14 multiplied 2 by 7, this will be 4, actually, sorry, 4, and why I'm taking this is objective function, that's why I'm doing a mistake. This is not the objective function. I've already written the objective function. You can remember there was 4 actually. So here we are getting 4. Here also 0. 4 and minus 4 will be 0. The first objective function J minus Cj. And the second will be, you are looking at 1 multiply 14. So there will be 14 and there will be 0. 14 0 minus 14, there will be also 0. So we will get again 4 0. Here we will get 2 0 minus 40 minus 0. There we will get 2 and at last we will get 0 minus 0. So we will get 0. So now in this objective function, in this Zj minus Cj, no one is negative, all are positive. So we don't need to form another table. We are getting the result of maximization. So here x2 is equal to 3, x2 is equal to 3. There are no negative values, all are positive values. So we don't need to find out more basic variables or basic matrix. This is the basic matrix formed by this table. So here related with x2, the value is x2 is 3 and x4 is 15. The other basic variables are equal to 0. x1 equal to x3 equal to 0. I hope you have understood. We have to need to maximize. So maximize it. Now if we put these values in the objective function, maximize z we will obtain just we have the objective function 4x1 14x2, 4x1 plus 14x2, and others will be 0 because of their coefficients are 0. So x2 just will be written down here. x2 is 3, x1 is 0. So this will be 12. So this is the best maximization, optimal solution you can say. You cannot obtain other through making other independent variables or in the independent vectors in the basis. You cannot get more maximization value of this objective function greater than 12. So it is the more maximized. In this way, the simple methods problem can be solved. So here one more question that it can be done or not, that you can there in the previous table you can look that there are two negatives of the of zj minus cj. One was minus 4 and one was minus 14. We have changed entering vector a3 a2 entering vector. If we will go take a1 entering vector and do the same table, then it is a very you can say a and different rate you will get the maximization will be then 14. I have done this. You can do this. That more negative I have taken minus 14 and we are getting 12. I have done this will be 14. Oh, 14 multiplied 3 is 42. 42. So this is the maximum value 42. And if you will take minus 4, not minus 14, then also you will get the same result, maximum 42. So there are no difference between these results, and we will get the same optimal solution, but basic values will be other. And there will be x1 and x4 will be the x1 and x3 will be the basic values. X1 and X2 will be the basic variables. If you replace minus 4 in the minus 4 means A1 is the entering vector. So there are many topics to discuss. I will discuss another problem in another video. So I hope you have understood this. And thanks for watching. If you like this video, then subscribe and share it yourself. Have a good day.